Hello everyone, we will consider this nice problem in real analysis. We want to show that there does not exist a continuous function defined on all the real numbers such that f composed with fx equals e to the minus x. So we argue by contradiction. We assume that such a function f of x does exist. Now, such a function must be one-to-one. So remember that one-to-one means that if x1 is not equal to x2, then the value f of x1 is not equal to the value of f of x2. Right, so we want to show that if such a function exists, it has to be one-to-one. So if it's not one-to-one, then there exists 2 points, x1 not equal to x2, such that f of x1 is equal to f of x2. But then e to the power minus x1, this is f of x1, right? So if f of x1 is equal to f of x2, then we will have equality here when we hit this by f. So we will have f of x1 equals f of x2 equals e to the minus x2, but this cannot happen unless x1 is equal to x2. So therefore, a function that satisfies this condition has to be one-to-one. So our next observation is that a continuous function which is one-to-one has to be monotone. In other words, it has to be either strictly increasing or strictly decreasing. Well, the reason is that if the function is not monotone, then it should have a local maximum or a local minimum at a point, and around that point a function cannot be one-to-one. So therefore a continuous one-to-one function is necessarily monotone. So our function f of x is continuous. We just showed that it's one-to-one. So therefore it has to be either strictly increasing or strictly decreasing. Now, if our function is strictly increasing, then x1 less than x2 will imply that f of x1 is less than f of x2 because it's strictly increasing. And if we apply f once again, we will get f of x1 is less than f of x2. Right? So in conclusion, f of x should be strictly increasing, but that cannot be the case because f of x is e to the minus x, and that this e to the minus x function is not a strictly increasing function. In fact, it's a strictly decreasing function. So that's how we get a contradiction. So in other words, our function, which f of x, which has to be monotone, cannot be strictly increasing. So let's see if the function can be strictly decreasing. So if f of x is strictly decreasing, then x1 less than x2 will imply that f of x1 is greater than f of x2 because our function is decreasing. So when we hit this by f, the inequality will reverse. But when we hit it by f again, the equality will reverse once more. And we will get f of x1 is less than f of x2. So in conclusion, if x1 is less than x2, f of x1 will be less than f of x2. Again, this will show that f composed with f is strictly increasing. And that's again a contradiction because f composed with itself of x is equal to e to the minus x, which is not a strictly increasing function. So therefore, if such a function exists, it has to be either strictly increasing or strictly decreasing. However, we proved that there is a contradiction in both of the cases. So the conclusion is that such a continuous function f of x that satisfies this condition cannot exist. So one observation here is that the only property of the e to the x that we used is that e to the x is a strictly decreasing continuous function. So if we replace this equality by any other strictly decreasing continuous function, then again a function f that satisfies f of x equals that function cannot exist. All right, so thank you for watching.